Hey guys, we're going to take a look at confidence intervals for lesson 8.1. And there are actually two more lessons in this chapter, but for this particular lesson, we're just going to look at the basics of like what is a confidence interval and what are the components and what conditions must be satisfied before we actually carry out the construction of an interval. So let's begin. So the first question in your skinny, I think this is on page 108. If you would follow along and enter in the definitions. Now at first glance, this lesson is going to be like, what the heck is going on? But I promise over time, with a little bit of practice, you're really going to like this chapter. So what I need you to understand for a point estimator is that it's a statistic that best represents our population. Now I want you to remember that parameter and population go hand in hand with one another. So if you're asked to talk about a parameter, it's a measurement that explains our population. And we're trying to always estimate that because the reality is we often don't have the money or the time to actually know what's going on with our population, so we're trying to make predictions. Question number 2 in your skinny asks us for the value of the point estimator statistic, and what is it called? So it's called a point estimate, and it is our best guess at the value of an unknown parameter. So we use the point estimate to make predictions on our population parameter. Lots of vocabulary. So don't tell anyone, but your crazy stats teacher decided to skip over chapter 7. So this part's going to be a lot to take in. So let's look at some facts regarding sampling distributions. We want to talk about shape, we want to talk about where the center is, and we want to talk about spread. So before I even load you with all of that, let's talk about some shapes we've studied in statistics. One popular shape is the normal distribution. So we're going to always check for normal. We have to make sure those conditions are satisfied. After we check for normal, we're going to check for, we're going to calculate what the center is, and then we also have to know like what the standard deviation is of our normal distribution. So let's take a look at it. There are two different categories. Well, first of all, maybe you're told that the population is already normal, and then you don't have to do anything else. And then normal is automatically satisfied. If you're not told that the distribution is normal, you have to look for your sample count for means, or you have to do a calculation for proportions. We're going to get into that in class. Just know that the distribution we're going to assume is normal as long as our sample size is at least 30 when we're dealing with means. If we're not dealing with means and we're dealing with proportions, you're going to take n times p and you're going to take n times 1 minus p. And you want to make sure that those products are at least 10 in order to confirm a normal distribution. For our center, if you're dealing with proportions, your center is just going to be the proportion given to you. And if it's means, it's going to be the mean that's given to you. That one's easy. And then to calculate standard deviation, oh, my picture's in the way. Let me take that off for a minute. I don't know if you guys could still see my face, but you have two formulas for spread, and it just depends if you're looking for the standard deviation with proportions or the standard deviation for means. Now, we have to confirm that the 10% condition is satisfied first before we carry out these calculations. Please make sure that you write down these formulas in your Skinny, and I will show you in class how to implement them. Okay, so what is a confidence interval? You're going to see things like 95% confidence interval, 98% confidence interval. Like, you're going to be asked, how confident are you? The most common confidence interval in this class is probably a 95% confidence interval. And what does it mean? First of all, it's an interval or a range of values that we use to estimate how close we are to the population. So it's a range of values. It kind of looks like an ordered pair, but it's not an ordered pair. Like, what's your low number, what's your high number, and somewhere in the middle is our true. We're trying to capture our true parameter. In this case, if it's a 95% confidence interval, it means that we are 95% confident that we're going to actually capture the true parameter. Do not get this confused with a probability. Confidence intervals are not probabilities. It is just that the definition is I'm trying to be confident. And how confident am I that I'm going to capture the true parameter? In this case, I'm 95% confident. So the actual interval itself requires two numbers. You need your point estimate. Your point estimate is right in the middle. And then you're going to add and subtract off your error from that point estimate. So your error, when it's added on to the point estimate and when it's subtracted off, you actually have two numbers that look like your ordered pair. It's not an ordered pair, it's a range of values. And this is where the numbers come from. Your point estimate is either going to be x bar, which is your sample mean, or it's going to be p hat, which is your sample proportion. So whether you're dealing with means or proportions, it's your middle number. You're then going to take that number and you're going to add and subtract off your error. So we're trying to figure out how close the estimate is to the parameter in repeated sampling. A confidence interval versus the level of confidence. The verbiage in terms of interpretation are very different, so you want to make sure that you're careful in your interpretation of the confidence level. So what the level means is, in the long run, if you were to repeat every possible sample available, like if you could take every single possible sample out there, it's going to give us intervals, and C% of all of those samples are going to capture the true mean or the true proportion. So if I have a confidence level of 95, that means if I were to take every possible sample out there, then 95% of my intervals are going to capture the true population mean or the true population proportion. To come up with your margin of error, you need two numbers. You need your critical value, which is a Z star, and I'm going to show you how to find that. And then the other number you need is your standard deviation of the statistic, not of the population. It's of the statistic, and you're going to multiply those two together. And then last but not least, the fun is almost done. We're going to sketch and we're going to label a 95% confidence interval for the standard normal curve. So, standard normal curve. That means in the middle, if it's standardized, my mean is 0. And my standard deviation is 1. And I'm going to standardize it. And I want to be 95% confident that I'm going to capture the true parameter. So, look at that beautiful picture. I have shaded in 95% of my curve. That is the pink shaded in region. If the middle part is 95%, then that gives me 2 tails of 2.5% each. So where are those lines, that orange line, where does that occur? Well, in this case, that's your Z star, your critical value. It's very critical because it's the cutoff point of my 95% confidence interval. So you want to figure out what that number is. And the way we do that is we do inverse norm. So essentially, remember, to find a percentile, we would go in, we'd do inverse norm, and then we'd want to know the area of the curve to the left. So in this case, I could go inverse norm. The area to the left is 2.5%, which we type in as 0.025. And then my mean is 0 and my standard deviation is 1. You're going to get a z-score, a critical value of -196. Now you can kind of cheat. If you know the left, you actually know the right because this is symmetrical distribution. So the positive critical value is also 196. But if you just want to check it, you could plug that inverse norm in your calculator, but you'd have to add these two areas together because remember that's a percentile. So 95 plus 2.5 is 97.5%. So you would do inverse norm 0.975 with a mean of 0 and a standard deviation of 1. Oh, that was a lot, but hopefully that helped you fill out your skinny. When you come back to class, we're going to actually take all of these weird new thoughts and rules and we're going to actually work with them and see how it affects our calculations. I hope that helps you guys, and calculator.